All right, section 9.4, we build on what we learned in 9.3 with angles and get into our most basic shape of a triangle. Tri meaning three, right? Three angles, three sides in a triangle. So our learning targets for today, we're going to find missing angle measures of a triangle and then be able to classify a triangle based on its angle measures and by its side lengths. So triangle is the most basic shape, right? I mean, if you think about it, if you just have one segment, right, you have a line, okay, and then if I add in a second segment, I have an angle, all right, and when I have this third segment, now all of a sudden I have a triangle, right, that has one, two, three sides, and one, two, three angles. All right. Um, so there's some interesting things about triangles, and one of the main concepts that we're going to look at today is the fact that three angles of a triangle will always add up to 180 degrees. All right. So this angle here, this angle here, and this angle here, right? And I should probably make sure that I don't confuse you, right? There's one, two, three angles. The three of them will always total up to 180. So if I know two of the angles, I should know what the third one is, right? Because I know that 35 plus 85 plus something equals 180, right? These three always total up to 180. So I can see here that if I add these two together, right, I've used 120 of the 180. So I should be able to say, all right, well, that's going to be 60, right? But I remember to solve this, I just use the inverse operation of subtraction, and I'm left with x equals 60. All right, so we know that the three of them add up to 180. We can use that fact to find what the missing angle measure is. So I would like you to practice on these two. So pause the video here and see if you can find the missing angle measures. All right, so let's see how you did, right? In the first one, set up the missing angle. I just call it x. You can call it whatever you want. Plus the 20 degrees plus the 130 has to total up to 180, right? So these two angles have measures totaling 150, right? Which means I have 30 degrees left over for the x, right? If we subtract 150 from both sides, we're left with x equals 30. In the second one, it looks like there's only one measure given, but remember this notation right here means 90 degrees, right? It means it's a right angle. So we have this 90 and the 40, and something else has to total up to 180. So if I combine the two that I know, 90 and 40, I get 130. Subtract that from both sides, we're left with x equals 50 degrees. Now, we're going to look at using some algebra to find missing angle measures, right? So it says, what are the three measures of the three angles on the triangle? So we take the fact that we know that it totals up to 180, right? And then it has three angles that total that. So my first angle is 84. So I'm going to add that to, sorry, lagging a little bit there. I'm going to add that to x plus 59, right? That's that angle. And I also have this x plus 51. So now we have to use algebra to solve this, right? So I'm going to start with my left side and my right side. So my right side's easy. It's just 180. But over here, I have like terms, right? I have 1x here and I have another x here. So I have 2x, right, when I combine them together. And then my values, I have 84, 59, and 51. So if we add together 84 plus 59 plus 51, we should get 194. So I have 2x plus 194 equals 180. All right, so now we have to solve this. So we start with inverse operations, right? I'm going to minus 194 from both sides. So I'd have 2x equals negative 14. So I divide by 2, and I get x equals negative 7. And you might be thinking, negative 7, how can an angle be negative 7 on a triangle? And it's not the angle that's negative 7, it's the value of x that's negative 7. So I want to find what the three angle measures are, right? So I already know 84, right? Because it tells me that's 84 degrees. This one says it's x plus 59, so I have to do negative 7 plus 59, and I should get 52 degrees. And then if I plug in a negative 7 right here, I should get 44 degrees. So my three angle measures are 84, 52, and 44, right? And if we check that out by adding 84 plus 52 plus 44, our calculator tell you that these three total up to 180 degrees, all right, which it should. So this one we had to solve for x and then plug it back in to find the angle measures. All right, let's look at another example here. So again, I know my total is 180. Then I have to add the three angles together. So I'll start with this one. 3x, sorry, that's not a plus, that's a minus 17. So we have minus 17. And then I have x plus 40. And I'm going to add that to 2x minus 5. So let's combine our x terms. We have 3, right? That's really a 1, and here's a 2. So 3 plus 1 plus 2 gives me 6x. And then my numbers, negative 17, positive 40, right? And that's really a negative 5. So negative 17, positive 40, and negative 5 leaves me with positive 18 equals 180. So to solve, right, we have to do inverse operation. So I'm going to start by subtracting 18 from both sides. So we get 6x equals 162. And then if we divide both sides by 6, we get x equals 27. Now, if we look up here at our previous examples, right, we're finding just that. We were done. That was the value of x. That was the angle measure. Here, that's not the angle measure, right? It's what x equals. So I have to plug that in. So here I'd have to do 27 plus 40. Here I'd have to do 2 times 27 minus 5. And here I'd have to do 3 times 27 minus 17. So if we plug those values in, let's start with 3 times 27 minus 17. This top angle is going to be 64. So 64 degrees is one of them. And if we go to this one here, 27 plus 40, we get 67. So 67 degrees. And then 2 times 27 minus 5 gives me 49. So my third angle is 49 degrees. Now, to check, right, I'm going to add 64 plus 67 plus 49. And these three total up to 180 degrees. So those are my three angle measures on that triangle. All right, using ratios, right, of 1 to 4 to 7. So it's not telling us what the angle measures are, it's just telling us their ratio between each other, right? Meaning that this one's 4 times bigger and this one would be 7 times bigger than the first one. So again, I have to take the fact that the total is 180. And now my ratio is 1 times something plus 4 times that same thing plus 7 times something, right? That would give me the ratio of 1 to 4 to 7. So to solve, right, these are all like terms, right? 1 and 4 is 5, and 7 more would be 12x equals 180, right? So if I take 180 and divide it by 12, we get x equals 15. Now, the question says, what are the three angle measures? The three angle measures are not 15, right? I have to actually plug that in for x. So one of my angles is going to be 15 because 1 times 15 is 15. And then my other angle, right, I'll just write that here so we know where that came from, would be 4 times 15, right, which would be 60. And then my last one would be 7 times 15, which would be 105. All right, and then if I added 15 plus 60 plus 105, that totals up to 180 degrees. All right, so I had to find x again and plug it in to solve. All right, our second learning target for today is just to classify triangles by sides and also by angle. We have scalene, isosceles, and equilateral. Okay, a scalene triangle has no congruent sides, which means the side lengths are all different from one another, right? So here, right, would be a scalene. Maybe this is 2, this is 12, and let's say maybe this is 13. Something like that. So you can see that they are 3 different side lengths. Now, if they just give you a triangle with no measurements on it, it's assumed to be a scalene. What they'll do if they're the same or different, they'll do these markings that look like this. So like they'll say that's one side length, there's another side length, and that side length is totally different. All right. For isosceles, has at least 2 congruent sides. So it could have 3 and it'd still be, but we really call that equilateral. So isosceles, we're looking for 2 congruent sides, meaning 2 of the sides are the same length. So if I have this triangle here, let me change color. It'll say this and this. So since they have the same little tick marks on there, that's saying that those sides are the same measure, right? Maybe they're both 4, maybe they're both 8, but 2 of the sides have the same measure and one of them is different. And then equilateral, all the sides are the same, right? Equilateral triangle, meaning this, this, and this are all the same measure, 3 congruent sides. Now, by angles, right? And we learned these terms back in section 9.3, right? So acute simply means that the angle is less than 90. Here the angle is greater than 90, and a right triangle is where it equals 90. Okay, so remember, we only get 180 degrees total. So really, you're classifying based on the largest angle. right? If the largest angle is acute, that means the other ones are going to be acute as well because they're smaller than that. So all three angles are acute. It's an acute triangle. Um, to be an obtuse triangle, it just has to have one angle that is obtuse, right? And it can only have one. And we'll talk about that a little bit later. And then same with the right triangle. One of the angles is 90 degrees. It'll be the largest angle in that triangle, and it's going to be 90 degrees. The other two will be acute. So if you have one that's 90 degrees, we call that a right triangle. So some key concepts. Scalene triangles. If three sides are different, then the three angle measures will also be different. All right. Meaning if you have sides, maybe 10, 11, and 12, all right, your angle measures will be three different angle measures. On an isosceles triangle, you have two sides that are the same. You'll also have two angles that are the same, right? Meaning if I draw a quick sketch, right, if those angles are the same, if those sides are the same, these angles will also be the same. And then equilateral triangle, since three sides all have the same measure, the three angles will also have the same measure, and they have to be 60 degrees because 60 plus 60 plus 60 equals 180. Now, this is what I hinted to before. Obtuse triangles can only have one obtuse angles, and the other two must be acute, all right, because all three have to add to 180. So if you think about it, the smallest obtuse angle is 91, all right? So let's say that I had one of the angles that was 91, that's the smallest obtuse, and another one that's the smallest obtuse. This already totals 182, right? And that's more than we have. So I can't total up to more than one. I have to equal 180, and I still have a third angle that's not there. So you only can have one obtuse angle in a triangle. And then right triangle, same logic there, a 90-degree angle. If you have a 90, and then another one's a 90, right? That's already 180 degrees, and you're still missing this third angle, right? And if you think about a 90 degree, right, goes there, and then if I go another 90 degree, I'll never be able to connect those, right? They won't, I'll need a fourth side to connect them, so that's not a triangle. So right triangle, 90 degrees is the biggest angle, and it's the only one that it could possibly have. The other two must be acute. All right, so let's classify based on angles and sides. All right, so if I look here, I'll go to my largest angle, which is 90. So this is going to be a right triangle. And then by side length, 7, 11, and 13.2, that would be scalene. Right? I could also just look at the angles. Notice that 32, 90, and 58 are three different angle measures. That means the sides are going to all be different as well. Here, largest angle is 128. That's obtuse. And I can see that two of the angles are the same, right? Which means two sides are the same, those two. So that would be isosceles. Number three sides are the same, right? So are the angles, right? They're all acute, largest angle 60. So this would be an acute equilateral. It's supposed to be an I there, equilateral. All right, so take a second and see if you can classify 4, 5, and 6. So pause the video and classify by and side. All right, number 4 is a right, right? Remember this notation right here means right angle, and two sides, two angles are the same, so it's isosceles. Here, the largest angle is 72, that's acute, and two of them are the same, right? And two sides are the same, that would be isosceles. Here, three different side lengths, that's scalene. The largest angle is 79, which means that it is acute. All right, so I'm going to have you practice the following problems starting on page 456. If you have questions, please stop down and see me.